Let's take a look at another example. This one might be a little bit more challenging. Let's go ahead and find the sum of the following arithmetic sequence. 51 plus 54 plus 57 plus 60 all the way up until we get to our last term, and we're going to be adding 84. As we take a look at this sequence, let's go ahead and identify the pieces that we know. We know our first term is 51. We also know our common difference. That's probably an easy piece for us to recognize. The common difference in this example is going to be 3. I can take any two terms and subtract them to get that common difference. So 54 minus 51 is going to give me a difference of 3. The same thing would happen if I chose 57 and subtracted the 54. And we also know our nth term. Our last term in the sequence is 84. The more difficult piece to figure out is how many terms we have in this sequence. Obviously, we could continue listing out all the numbers and then just count them. That's one way we could do it. If we had a lot of terms, that's going to be a really tedious task. So let's talk about a different approach instead. So we're going to go back to a formula that we've used in the past. We're going to use this formula to find our n value. We have a sub n equals a sub 1 plus n minus 1 times d, which is our common difference. Let's go ahead and plug in the pieces that we know. Be careful when you're plugging in here. Keep in mind we are looking for our n value. We know our a sub n, which is our nth term, was 84. We know our first term, a sub 1, was 51. And we know the common difference was 3. So we're going to be solving this equation for n. I'm going to go ahead and distribute the 3 to each piece inside that set of parentheses. So my new equation now is going to read 84 equals 51 plus 3n minus 3. Let's go ahead and finish solving this for n. When we do that, we're going to end up with an n value of 12. So we obviously have 12 terms in this sequence. Now let's go ahead and use that information to help us find the sum. Let's go back to the formula that we need. Here's our formula for our sum. We have s sub n equals n over 2 times the quantity a sub 1 plus a sub n. Let's go ahead and plug in all the pieces that we have. We had a total of 12 terms in our sequence, so we have 12 divided by 2. Our first term was 51, and our nth term was 84. So as we finish working this out, the sum for the sequence comes out to be 810.